Hello one more time. I can hear some dogs barking because I'm yelling here like a madman because whatever I do with the volume, this mic is not loud enough. I don't know why, I'm probably stupid. We need to talk about limiting reactants right now, and that's one of the things that confuses most people that start when they start dealing with chemistry. It's actually very simple. You just need to stay focused when you do this. So let's again uh, have an example of our favorite reaction, H2 plus O2, and that yields H2O and balance it by 2 and 2, right? So, the thing is, I know 2 moles of this react with 1 mole of this, and that gives me 2 moles of water. However, what if I have 2 moles of this and 2 moles of this? That's the question. So if I've got 2 moles of this and 2 moles of this, what happens now? Well, you see that 2 moles of hydrogen actually only need 1 mole of oxygen. So in the end, when this reaction is finished, assuming it's completely going to go to the right side, I will end up with 2 moles of this, 0 moles of this, right? Because I had 2, but they reacted. But here, I'll have 1 mole of oxygen left. Why? Because, again, hydrogen needs double the moles of oxygen. So if I have 2 moles of hydrogen, that means that I will need only 1 here. So the second one will stay. So this is and the end. And this is in the beginning. This is initial. Initial is the beginning. So, in the beginning, I had zero water, right? And then I had 2 of this and 2 of this, and the end I got these. So, the thing is, this reactant here, because there's more of it than you need, is called excess. Excess, I mean, the word itself tells the story, means you've got too much of it. This one, however, is you have just enough of it, and that's called limiting. That's called limiting reactant. Why this is called a limiting reactant? Because this one limits how much water I can actually get. It limits the reaction. And this one is in excess. I've got too much of it. And these questions look easy, right? I mean, you saw this. This is not doesn't look difficult at all, right? How is this difficult? However, it does get confusing when this is uh, entangled with more stoichiometry. So I will give you many questions about this. We'll also do some examples right now. So let's just wipe this off and do a different reaction. So let's say I've got the same reaction. Actually, not a different reaction, just a different example. So let's say I've got 5 grams of this and I've got 7 grams of this. And let's say I need to know right now what is happening here. I need to determine how much water I will get. What's the limiting reactant? What's the excess reactant? So again, just like in every other stoichiometry problem, you will want to turn this into moles. And I will go more quickly right now so you can use the whole proportion thing. I'm just going to use my phone to calculate this quickly because I don't want you to waste time. So basically, when we want to switch these into the moles, so 5 grams of hydrogen, so 1 mole of hydrogen is 2 grams. So 1 mole of hydrogen is 2 grams. You forget this 2. This 2 is not involved with this. So 1 mole of H2 is 2 grams. So 5 grams of H2, that is going to be 2.5 moles, right? And here, 1 mole of oxygen is 16 grams. So basically, we need to divide 7 with 16. And not 16, 32, sorry. So oxygen is 32 grams O2. So 7 divided by 32, and you're going to get 0.219 moles of this. So what happens now? In the beginning of this reaction, so this is the initial phase. So initial phase, basically we've got this many moles of hydrogen, this many moles of oxygen, and 0 moles of water, right? And then the reaction happened. When the reaction happened, this reacted with this, but 2.5 moles of hydrogen, H2, cannot really react because there's not enough oxygen. Get it? So to react 2.5 moles of hydrogen, I would need half of that of oxygen. So I need 1.25 moles of this. I don't have it. So obviously this is the limiting reactant. Obviously this is the limiting. And I can just put an L here. And again, how did I determine this? Like, let's say I want to react 2.5 moles of H2. How many moles of O2 would I need? Well, they're 2 to 1, right? So if it's 2 to 1, then it's 2.5 to 1.25. But I don't have that much. So that makes this a limiting reactant, and then that makes this an excess reactant. So I need to base my calculation on this here. So this one is going to be spent. All of it is going to be spent. So all of it is going to be reacted, and then at the end, I will have 0 of this left, right? All of it is going to react, right? But how much water will I get? Well, you see, 1 mole of oxygen will give us 2 moles of water. So 0.219 moles of oxygen will give us double that water. So I just need to multiply this 0.219, multiply this by 2, and I will get here 0.438 moles of water, right? And now I can just take this and turn this into grams very easily. I can just, how do I turn this into gram? Well, 1 mole of water is 18, so I just multiply this by 18 and I get grams of water. Easy peasy. Now, what about hydrogen? So basically, for hydrogen, the situation is a bit different. Why? Well, I had 2.5 moles, right? How much of that did I lose? Well, I had this much oxygen, and this much oxygen needs double that of hydrogen because they're 1 to 2. So if I had 1 mole here, I would need 2 moles of hydrogen. But I've got this many moles of oxygen, I would need double that of hydrogen. So double that would be minus 0.438 moles. And that would be, let me use my stupid calculator. I would have 2.062 moles of this left. 2.062 moles of this left. And so at the end, I can easily calculate how many grams of this I have left, how many grams of this I got at the end. I can even calculate how many grams of hydrogen I spent. And again, I just turned this into the moles because the moles are what you are supposed to be looking at. But they can give you these questions with grams. They can give you these questions with volume. They can give you even the number of molecules, atoms, and so on. So I have found a bunch of good questions. Let me just find it. Okay. For example, this one. This website has some good stoichiometry questions, for example. So how do I do this? Titanium reacts with nitrogen gas to produce titanium 4 nitride. So this according to the balanced equation. Okay. Suppose that 88.1 grams of Ti are combined with 3.89 moles of N2 in a reaction chamber. Identify the limiting reactant. Okay, let's break this one down. This one is interesting and frankly pretty easy. So let's write it down. 3Ti plus 2N2, and that yields Ti3 and 4. So what did I say? I got 88.1 grams of this. 88.1 grams of titanium, and I've got 3.89 moles of this. So they've given us the moles, so we don't need to calculate the moles of this. The only thing we need to calculate is the moles of this. So how do I do this? Again, you can do the proportion. You can just make it easier and divide this with the molar mass of titanium, which I of course don't know. I don't even know where to find titanium here. Okay, 47.9, let's say. 47.9. So divide this with 47.9, and what we've got will be 88. 1.84 moles of this I've got, and that reacts with 3.89 moles of this. And that is going to be my initial situation, right? And of course 0 moles of this one. So what do I want to do with this? I want to determine which one is the limiting, which one is the excess. So you see, these two are supposed to be 3 to 2. So let's assume this is limiting. If this is limiting, let's see how much of this will we need to react with this much. We'll need, I mean, that's 50% less basically. So for this to react with this here, we're still gonna have some of this as excess. So that can work, but let's look at the opposite situation. So if I have this much, I would need more of this. Right? So if this is the limiting reactant, if all of this is spent, how much of titanium would I need? Well, more, because they're 2 to 3. So that situation is not possible. It's not possible for this one to be limiting. So I know right away that this is limiting and this is excess. So again, you look at them like this. You pick the first one. You say, okay, can this one be limiting? Let's see. 1.84 would need less than 1.84 to react. That's possible, so this one can be limiting. But what if this one were limiting? If this is limiting, I would need more of this, and I don't have it. So that's an impossible situation. And how do I know this? Because this is 2 to 3, right? 2 to 3 means that if I had 3.89 of this, I'm going to need more. So that's an impossible situation. So again, titanium must be a limiting reactant. So I can easily find now what's going to happen at the end. So at the end, let's see. Since this is limiting, at the end, there's going to be 0 of this left, right? What's going to happen with this one? So, see, titanium and Ti3 and 4 are 3 to 1, right? 3 to 1. So if I have this much titanium, I'm going to have 3 times less of the first one. So all I need to do to determine how much Ti3 and 4 I am getting is just divide 1.84 with 3. I divide it by 3 and I get 0.613. Now what about this one? Well, again, you always put this one on the side just in case. So I had 3.89, right? How much has reacted? So if this is the limiting reactant, how much of this is going to react? Well, they're 3 to 2. So you can use a proportion. You can say, if I have 3 moles of titanium, that's going to react with 2 moles of N2. But I've got only 1.84 moles of titanium. How many moles of nitrogen do I need to react with that? And when you do this, then you see that X equals basically 1.84 multiplied by 2 and divided by 3. And that's going to be 1.22 moles of N2 has reacted. So I have this much reacted, and what is going to be left is you just deduct 2.67 moles of this is at the end. And now I've got this figured out. How do I get this figured out? Well, they're asking me here. Let's see what they're asking. I mean, we did everything, so they cannot possibly ask anything. Yeah. Calculate the mass in grams of titanium for nitride that will be produced. So we calculated the mass that will be produced. We calculate the moles. All we need to do is multiply the moles by molar mass, turn this into grams, and that's fine. Amount of excess reactants. Again, this is the excess reactant. We just need to multiply this by 28, which is the molar mass of N2. And again, we have a solution. So very, very easy to do. Okay, I'll give you a lot of practice with this. And for this one, really email me if you don't get it. And I can explain again one-on-one. Thank you and see you soon.